Okay, so we have a homework assignment due today, but it's a program. Sounds like you guys all don't need any help with that, right? It's pretty straightforward. Gave you the program, just had to modify it a little bit. I think you had to have a new, how did you do it? You had to have a new...
You have to have a new an other in the alphabet.
You have to have an other category to categorize the things. And then that meant that you had to have to change the table. The state transition table had to be modified, right? Had to be made a little bit bigger.
It was fun.
Yeah, it was very straightforward. Okay, so now at the end of class last time, oh yeah, question?
Why do you have to make the state transition table bigger?
Because there's another category of symbol.
But we don't care about the symbols, do we?
I do.
Well, I mean now, okay.
I said if it ever tries to do something else, just say it's not valid and be done, instead of telling it to do something.
Oh no, that's not a very good way to do it. I mean, what you should do is because there's a third category.
Alpha digit and
other.
Right.
And because there's a third category, there should be another column on the state transition table. Because otherwise you have all that extraneous code. You have a bunch of if statements you got to put in, blah blah blah. No. For the table lookup, you want to just go. And
you'll send it to those transitions, and then it will be fine.
Yeah. That'll make your code a lot cleaner. Yeah. That was the idea. I see what you did, and it worked. I'm sure it worked the same way, but still, I think your code's a lot cleaner. You know, letting the table actually doing the table lookup instead of intervening, because you had to intervene in the loop, right? I don't know. You might have had to do a break or something. I don't know. Yeah, this is kind of ugly, but anyway. Okay, so is everybody good? All right. At the end of class last time, we demoed this program that here in figure 7.19b is the state transition diagram for recognizing a signed or unsigned integer, right? And last time we demoed this program, which is here in figure 7.26. There's a screenshot. I'm not going to demo it again because we did it at the end of class last time. Okay? And remember what you do is it asks you to enter a number. If you enter a sequence of characters that are not a number, then the console output says invalid entry. And if you enter a number that is a valid signed integer, optional plus or hyphen character at the beginning, then it says number equals, and it gives you the number. Now, and like we said last time, you can't actually tell by just looking at this output whether it's just taking the string of characters and outputting that string of characters, you know, on the console. But it's not doing that. What it's actually doing is, and we'll see, I think you're going to like it, the code for this actually converts the number from, it converts the hyphen and the 5 and the 8 to actually an int, -58. Because this is what you're going to have to do, this is what your assembler is going to have to do. Your assembler is going to have to do the same kind of thing. Convert sequence of characters into numeric values. Okay, and now what are the two techniques for implementing finite state machines? Table lookup and? Well, we got the first one right. Direct code. Table lookup and direct code. And we said, and we just did table lookup, you handed that in, you're handing that in today. And so this is an example of direct code. And do you remember which one that we're going to be doing for the project?
Direct code.
We're going to be using direct code. So listen up here because this is how we're going to do it for the big one, for the big project, the translation project. So let's do a little code walkthrough. Figure 7.26 is the first part of the code for Java. Now, do you remember when I demoed this yesterday, there's more than one file? Did you catch that? Do you remember that?
I don't remember.
Okay, well let me just make a statement here, and it is that in Java the convention is one file per class. So it's not mandatory by the language. It's okay. It's legal to have two classes in one file, but the standard kind of like the standard way of doing things in Java, is to have one file per class. And then you rely on the IDE to manage all that plethora of files. That's what you're going to have in your project. You'll have a whole bunch of, you're going to have a whole bunch of classes in your translation project. And you're going to rely on NetBeans to manage all those files, because there will be one file per class. This one, I think there's going to be two classes, if I'm not mistaken, plus the main class. Okay, so this here, this figure is in file fig0726 main.java. All right, and you know, this graphical user interface is all just like we had before. All right, and this set up the main window, lay out the label and the field for the panel top to bottom, lay out the button, so that's all just like we did before, and combine the input panel and the button panel in the main window, blah, blah, blah. Is everybody good? So I think there's not much there. And then here is the, but now here we have to be careful to see how the main works. Okay, so there's our private static void create and show GUI that that actually sets up the, sets up the GUI, and then when we do, and then we call create and show GUI in public static void main, right? And now here is our action performed. Now let's take a look at, this is the action performed, the code in action performed is, we have to understand how this works at the top level, because this is going to be, the organization is going to be like the organization that we do with our project. I mean, there's going to be some concepts here that we're going to have to emulate whenever you do your project. So check this out. It says, first of all, we have string line gets text field dot get text. Now, everybody understands what that does. Line is an object with class capital S string, and capital S string is a what? Java. Yeah. Well, it's a string class. Everybody with me on this? The upper classes are uppercase. Start with uppercase. Yeah. Okay. So string line gets it. Okay. So at that point, line would be, what was it, like -58. Okay. And now look, you guys, what we have now. On this next line, we say, it says capital P parser, lowercase p parser gets new parser. So now parser is another class that we have written for this program. Are you with me? So that's not Java, that's us. Yeah? So capital P parser, parser gets new parser. So that brings this parser into existence. Now, can you surmise what parser has in it? Can you surmise the methods that parser has in it from this code? What's the very next line? It says parser.parseNum parentheses line. So what is that parentheses line? Is that the actual parameter or the formal parameter? That's the actual parameter. And what line are we giving it? The line that contains the -58. Are you with me? Okay. And so it's calling the, oh, and what is the name of the method?
ParseNum.
ParseNum is the method. So does everybody clear that evidently this class parser has a method called parseNum? Are you with me? And furthermore, is it a void method or not?
Not void.
It's,
Oh.
It is.
how can you tell?
Because it's not set equal to anything.
Yeah, it's not set equal to anything. So what kind of a method is it?
Void.
It's a void method. Now, is everybody clear on that? Yeah? So it's void. Okay, so it's parser.parseNum line. Okay, so there's one method. And now, check out the next line. If parser dot what? Get valid. So now what does that tell us that parser has?
Another method.
Another method named what?
Get valid.
Get valid.
Boolean.
And it must be Boolean because it's used in an if statement. Are you with me? So what do you suppose get valid, what do you suppose a precondition of get valid is?
It has to be something in the language like plus, minus, or an integer.
Yeah, but in terms of the programming, what do you suppose has to happen before you can call getValid? You must have done what first?
Parsed it.
Yeah, you must. This assumes, do you see what I'm saying? So what must be happening is with that, when we do parser.parseNum, that is, we have to have done a parse before we can figure out if it's valid. Are you with me? So does everybody see how that works? And what can we surmise from that? There must be a what? Some sort of a attribute inside the parser that does what? Tells us whenever we do a parseNum,
It's valid or not?
that gets set, yeah, that remembers whether or not the parse that we did was valid. Are you with me? And furthermore, if parser.give, what do you do with system.out.printf? It says what? Number equals, and now what?
The parser.
%d,
Parser get number.
yeah, and what number is going to be printed out there? Parser.getNumber. So now what does that tell us?
It has a method that actually converts the characters to the real number.
Yeah, the getNumber, yeah. So getNumber actually returns the number, the numeric value that was parsed.
In integer form.
In integer form, yes. It returns it in integer format.
So it's like a decimal output trap rather than character output.
Yeah, you could think of, I guess you could kind of think of it that way. But you see, what happens was, so this getNumber, this, okay, so what three methods did we say?
GetValid. Parsenum.
Yeah, parseNum, getValid, and getNumber. And probably what's going to happen is getNumber will probably be undefined if getValid is false. Right? Because you see how we guarded it with the if statement there. We only called getNumber if getValid was true. Are you with me? Does everybody see that? All right, now let's go back to the state transition diagram that we are implementing, figure 719. Now how many states do we have here? 3, and they are named? I, F, and M. Are you with me? So the next piece of code then is a whole new file that has just one thing in it. The name of the file is state.java. Are you with me? Now I think this might be the first time we've used enumerateds in Java. Is it? But we've done enums before a lot in C++, right? Oh, wait a minute, or have we done enums in Java?
Not in
Maybe.
Java. We only did the enum for the red-black trees, right?
Yeah, maybe so. Maybe,
Paradigms.
yeah, maybe I'm mixing, maybe maybe I'm not remembering. Okay, but now how many states did our finite state machine have that we were implementing? How many?
3.
Yeah, 3. But how many enum values do we have here?
4.
We have 4. Now here's something that's way different between Java enums and C++ enums. C++ enums are equivalent to integers. However, Java enums aren't equivalent to integers. They are, a Java enum is an object. It's not just an integer, it's a whole object. So it has methods. Do you see what I mean? Is everybody clear on that? A C++ enum is equivalent to an integer, and so it's very efficient. A Java enum, however, is an if it has this type, it's actually it's an object. So it can do more stuff. There are methods that you can do with Java enums that are built into the Java language for enums, and we'll see what they are as we encounter them. Okay, now is everybody clear with that? So there's that one class. And now what's the other class that we have?
The parse.
The
Parser.
The parser class. Did we? Oh, by the way, let's go back to here. Here in figure 7.26, the very first part. Do you see how where it says import java.da-da-da, java.da? There's no import. What seems to be missing here?
You don't include the other files.
Yeah. What about import the state? and import the Java. Well, okay, in Java what happens is if those are in the same directory as the main, then you don't need to include them. Or actually in Java, import them. Yeah? So that's a rule. So as long as they're all in the same directory, and what I recommend you do is, you know, there are in really big projects that are team projects, then you would have your projects would be in a bunch of different directories, and you would have to include them, and there would be teams of people, and there's rules for how to do that, and there's lots of Java mechanisms to manage all that stuff. I just recommend that you keep all of your. Actually, it'll be necessary for me to grade these with my scripts. For you to keep all of your files, separate files, that one file per class in the same directory. And then when you zip it up with your .jar file, everything will work with my scripts. Okay, so is everybody clear on that? All right, so now you guys, here comes file parser.java. Okay, so let's take a look at this parser.java. Now, what's one thing that we notice here? It's public class.
It's not static?
Yeah, it's not static. It's public. Because we're going to do a new. Remember how at the beginning we did new? Remember how we did new? By the way, what did we give it when we did new? What was that? When we did new.
Parser gets new parser.
Yeah, it was, here, let's go back. It was capital P parser, lowercase parser gets new parser, and then what did we say? We said parser.parseNum line.
Yes, we fed it a string.
So we fed it a string, the parseNum, we fed it a string. Is everybody good? Mm-hmm. Okay, so but now you guys, maybe we should probably do a UML diagram on this. I don't have a slide up with a UML diagram, but we should do it. So look at this. We have public class parser, and now what is this private Boolean valid initialized to false? So what is that called in object-oriented?
Attribute?
That's an attribute. So what's the name of it? So here, let's go over here. So what is, remember UML, what's UML stand for? Unified Modeling Language. The name of the class, remember there's 3 compartments to a box. The first box is the what? Name of the class, right? This one here. So here it's parser. Okay. And then what goes here?
Private attributes.
Yeah, and do you remember the attributes? Yeah, the attributes go here. And what is the symbol, UML symbol for private?
Private is a minus?
It's a minus.
Or
Yeah, private is minus, right. Okay, so it's hyphen. So hyphen, and what's this attribute? Valid, and it's type Boolean. So remember how this worked? Valid, Boolean. Is everybody clear on that? And then what other attribute does it have? Number, and it's an int, and that's also private?
Mm-hmm.
Okay, so that's minus number, and that's type int. And I think those are the attributes, right? Mm-hmm. Okay, and now what goes in the third box? The methods, the operations. And now which ones do we have here?
get valid?
Yeah, public, get valid. So public was what?
Plus.
Plus. And does this return a...
Boolean.
It's a Boolean. So this is get valid. And no parameters, but it returns type Boolean. And look at you guys, it's a one-liner, right? Basically, what does it do? What does get valid do? It returns this one. Are you with me? And then what's the next one?
Get number.
Get number. And that's type what?
Int string.
Int.
And it returns
Int or integer? Int. Okay. Yeah. And furthermore, that's another one-liner. What does it do?
Returns number.
Yeah. And then we have another one.
is digit.
Is digit.
It's going to be a Boolean.
Only is digit gives you a...
Parameter.
Has a parameter.
yeah. So this is ch of type char. And it returns Boolean, right? And does everybody see how that works? That's another one-liner. Mm-hmm. Yeah? Are we good? And now what was the last one?
Parser.
Parse num.
Parse num.
Okay, so boom, here's first screen of parse num. And what is that? Public. So plus parse num. And what do we give it?
The string.
A string. So here's line of type string, capital S string. So, so everybody understands the structure of a parser.
Since it's void, we don't put anything after.
Oh, and since it's void, yeah, I guess we could say void here if we want. Okay, so here's the UML of our, this is the structure of our parser. And we've already seen the code, we've seen what these are, we've seen the code for this, right? And by the way, these were, well, doesn't matter, make too much difference how this is initialized. Okay, so now, I don't want to keep switching back and forth to that state trans, well, okay, we'll do it one more time. So here in figure 7.19b is the machine that we are going to,
Try it on the board.
yeah, we could. Maybe we should, well, all right. Okay, so you want to, over here? So what is it? I. So here's start. And this is I. And then what's this one?
F.
F. And M. And it's to here
Plus or minus.
Plus or minus.
is plus or minus.
Digit.
To here is digit. Here is digit. And loops on itself on digit.
That wasn't good.
Oh, it wasn't. You're right. I shouldn't complain, huh? Okay, so
I had it, John. Said I had it.
all right. So check out what we're doing here. The first thing we're going to do is, now do you remember what we put in the for line? When we did hyphen 5.8, then what happens is line was quote hyphen, the hyphen, and then the 5, and then the 8, right? But now what does the first line of the parser do? It does line gets what? Line plus new line. So what do you think plus is in Java with the string? It's concatenation. Are you with me? So the Java type string you can, so now line is no longer this, it's hyphen 5, 8, and then a new line. Now why do we do that? This is a sentinel. When we go through our loop, we're going to use this as a sentinel. Are you with me? Yeah? And then what happens? Int line index gets 0. So what do you suppose that's going to telling us?
Where we're at.
The first one?
Yeah. That line index is going to go here and process these characters one at a time. Are you with me? And then what happens? Char, next char. It's not initialized to anything, but anyway, it's a next. That's what we're calling next char here. Okay, next char. Are you with me? Okay. And then what happens? Int. Now check this out. Int sign gets +1. So here's sign, and that's an int, and it gets +1. Is everybody clear?
What's
Well,
that plus? Is it?
well, I just put that there for a little documentation. You'll see in a minute. It's a mystery. Ooh, why is... Well, I mean, I could have put just 1, but I put that there to emphasize something. Okay, it's a little self-documentation. Okay, and now, but now, why isn't this Boolean valid gets true?
Because
you're going to try to prove it false.
No, but why?
That's our attribute for the class.
That is the attribute. Does everybody understand that valid is this valid? It's already been declared up here as an attribute of the class. Now, is everybody clear on that? Because what are these? What kind of variable? What kind of variable is this? These are locals. And what kind of variable is this? That's a parameter. Are you with me? This one's a parameter. These are locals, but that valid is this attribute. Is everybody with me? Because we're in a parser and it has this. Yeah. And so what does that valid get?
True.
It gets true. So we'll keep track of it here, but we have to remember that this is an attribute. Is everybody with me on this? Okay. So now, you guys, this is way cool. All right. So now, oh, and then we have capital S state, lowercase state. So lowercase s state is an object,
In the class state.
and it's of type state. Well, it's an enum. Remember, we defined capital S state, and the enumerated values. So little lowercase s state can have any one of those states. And what do we initialize it to?
The initial state.
Yeah, and notice how we have to specify the value. We give the name of the class, dot, and then the enum value. Are you with me on that? So, and that is called, remember how on the other one we had what was called the state variable? So this is the state variable. This time they are enum values. So it's s, what is it? State dot. Okay, I'll just omit the state dot. Okay, so it was s dot I or s underscore I. Is that what it was?
Yeah.
Okay, is everybody good? Okay, so now you guys, here we go. Dun 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 dun. Do. Do what? Where's the end of this do?
Oh, that's right. It checks at the end of the statement.
It's do while. Are you with me? So it do all this while what? State is not equal to state.s stop. Now do you see why we have that other stop? Okay. And valid. But are we doing this check now the first time through the loop?
No.
No. So anytime you have a do, what does that guarantee?
The loop executes once.
That guarantees that the loop executes once. But wait a minute. Wait a minute. What if the user didn't put anything in that text field and pressed the button?
It still executes though. Well,
But how do we know it would execute correctly? Because if it's going to execute once,
Because we set the valid to true.
well, yeah, we did set the valid to, but if it executes once and he didn't put anything in there, then what's it going to process? What character is it going to process?
Concatenated
What character is it going to process if
our end line.
our bash in? You see, so that's related. Are you with me? The fact that we can guarantee that there's at least one character in the string to process because we concatenated it with bash in. Now, does everybody see that logic? See, we're not, I don't think we're used to doing loops with a test at the end of them. So this is, this is a little bit different from what we're used to, yeah? But we can handle it. Does everybody see how those are related? Concatenating that, the test is at the bottom, that's all right. When we go through, we will process at least just this one, okay? So now, do. We're not doing the test now. Do. But no, so what happens? Next char gets what? Line dot char at, parentheses what? Line index plus plus. So that's not plus plus line index, it's line index plus plus. What's the current value of line index?
0.
Oh, we're not keeping track of it. I need to keep track of line index, huh?
0.
Yeah, okay. Can we keep track of that in our head?
Yes.
Okay, so that's 0. So therefore, what does next char get when we do that?
Line sub 0.
Our arrow is our line index.
Right.
Yes.
Oh, yeah.
So what is it? So what does next char get?
Minus.
It gets the hyphen, yeah. The hyphen. Now does everybody see that's what that gets? And not only that, after it gets that, what happens to line index? It goes plus plus. So now line index is here. But this is the one that we just got. Are we good? Okay, so post, you know that from C++, right? Now look at now here comes the direct code. Does everybody understand? We have switch, right? Switch. So switch in Java works just like switch in C++. What do we say? Switch what?
3 cases.
Yeah, but switch on what variable?
State.
State. So you see we have a switch on state. State is this, right? And so we have case, and so what cases do we have? All the cases, yeah. So here's case S underscore I, and then notice that's the case and then break. And then here is case SF, break, and then case break, and then else valid gets false. Now, it's interesting, what case do we not have here?
Stop.
Yeah, right, we don't have stop, because what's going to happen is the test says while state is what? Not equal to stop. So if it ever gets set to stop, when it gets to the termination, what will it do? It'll terminate, and so that we won't ever have a need for case. Now, does everybody see that? Okay, so this structure, you guys, is the structure for implementing a finite state machine with a direct code technique. It's one while loop, one do loop. Are you with me? You set the state, you set the initial state first. It's one do loop with one switch statement with a case on each state, and then with nested ifs inside each switch. Sorry, within each case. Let me say that again. It's a switch statement on the state with a case for each state and a nested if within each case. Does everybody see how that works? And if you deviate from this, you are in big trouble. Not from me, but your code will start to get extremely complicated very fast. If you break this pattern, this design idiom, then complications will begin ensuing, and you'll have a complication on top of a complication, and then this will break, and then this will break over there. Because what does this do? This does the finite state machine. And look at how it works. Let's trace through it here with this being hyphen. So first of all, it's switch state case s.i. State is s.i, right, or s underscore i, right? Mm-hmm. Okay. So let's go through the code. So what does it say? If what? Next char equals a plus. Is next char a plus? No. No. So what do we do? Else if next char is what? Hyphen. Is next char hyphen?
Yes.
Yes. So look what we do. Sign gets negative 1. So here, sign here is no longer plus 1. What is it? -1. It's -1. Are you with me? Okay. And then what happens? States get. Now, how do we know to say state gets s underscore f?
Because that's where the transition hyphen needs to be.
Yes. So you look right. Look here. You basically what you do is you look here. It's on this, you do this, the direct code. There's the direct code of this transition. So this is SF. Does everybody see how that works? We're in this state, we detected this, we go to this. And by the way, you guys, notice that what kind of a finite state machine is this?
Deterministic?
Yeah, what else? It wasn't. This is different from the one we did with the table lookup. A little bit.
Simplified?
It's simplified. Which means what?
There's no reject.
We don't have to have a transition from every one, to a garbage state that collects all this stuff. So how does this code work? How does it work being simplified? Look. What would happen if it were not plus here? What would happen if it were not hyphen? And then what's the next else if?
Is digit.
Else if is digit next here. What would happen if it's not that? What would happen?
Valid gets false.
It would say valid gets false, and then what would happen? It would while and valid. It would quit, and what would our valid here be? False. And our parse would be done, and when the user went to say if get valid, it wouldn't be valid, and he would know that it was. And furthermore, do you see, it wouldn't have to scan through all the rest of them because it's a simplified machine. So that's another thing about the direct code technique, is that it's easy to program in the simplified one, right? instead of having to have a garbage state that it goes to every time, or have a special one that says if it's, yeah? So does everybody see that? All right, so now where are we? Sign was -1,
Now
state is SF, and so here what happened here is we hit break. Yes, and once we hit break, we come down here while state. Now the state not equal to S_stop, true or false?
True.
True. Valid, true or false? Why was it true? Because we set it to true at the beginning. Notice that we had to do that. Yeah? Okay. So where do we go? Back up to the top of the do. Are you with me? So now what happens? Next char gets what?
5.
So now it's no longer hyphen, now it's 5. Now watch this, you guys.
You have to increment.
And then this goes up. Now I think this is going to be cool. Now watch this.
Go to S state.
Switch state. Now switch to what state?
SF.
SF. Now watch this. If is digit next char. Is digit next char true or false?
True.
True. Yeah, so now there, that section of code. And now look, number gets what? Next char minus what?
0.
Character 0. So what is that? What is here my question is, what is quote 5 minus quote 0, where these are characters? What does this equal?
5.
This equals the integer 5.
Oh.
Are you with me? Are you with me?
So it's the difference of the ASCII value.
It's the difference of the ASCII values,
That's what happens.
or Unicode values, by the way, which they may be. Because Java is very Unicode. I'm not sure if these might be Unicode values. In fact, I think they probably are.
But either way.
But either way, yeah.
It's like one of the programs we did for homework.
Yes, the one where we
Yeah.
to do is make it one.
Yeah. Okay. But then I want to make sure everyone understands that how this works. Okay. This is very C-ish. You know, this happens all the time in C. Okay. And what does number get? So now, we have another variable, number. What is number?
That's our attribute.
Oh, that's our attribute up here. Yeah, we'll keep track of. Oh, good call. So here we'll keep track of its value here. Okay. So our number gets, now watch this, it gets 5. Are you with me? And then what happens?
Change the state to SM.
Oh, you're right. It does change the state to SM. So SM, and why do we know that? Because we were in state F, we got a digit M. Are we good? Okay. And so then we hit break. Are you with me? We hit while. So we test a while. So what happens?
Go back to next char.
Yeah, because state is not equal to stop is true, valid is true. All right. So we go back to the top. And what happens here? Next char. So this becomes the character 8. All right. And our thing is, line index is here. Is everybody good? So this. Okay. And
State SM.
and now we go to state SM. Now watch state SM. This is so slick. This is just really clean and slick. Watch this. Case SM. If what?
Is digit.
Is digit next char. Is digit next char?
Yes.
Sure. You bet your sweet pippy. So now look what happens.
Nifty.
Now I want you to look at that line of code and tell me that's not slick. Tell me that's not slick. What does it do? It takes 5, does what?
Multiplies it by 10.
Multiplies it by 10. That makes it what? 50. And then does what? Adds
Next char minus 0.
next char minus 0, which is the 8, which makes the number what? 58.
And that only happens on SM because...
And that only happens on SM as we're collecting digits.
Oh, and it'll just continue to do it.
And it will, if there were 5, 8, 9, 3, 2,
And because
it would, each time, like if there were another digit, this would be what? 580 plus what the value of that digit is.
The numbers are base 10.
Because our numbers are base 10.
What about the negative then?
Well, let's keep going. All right. So now, okay, but is everybody clear on that? And it stays safe.
By sign.
Yeah. Wait. You're getting ahead of me here. Okay, let's walk it through a little bit. Okay, then break, boom, Back up to here. Okay, oops, I went too far. Oh, wait.
Next char gets bash in.
Yeah, back up to here. Next char gets bash in.
Does it get bash n or just bash?
No, 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 no. This bash in is, this is exactly the same way it's done in assembly language. And in C. And in C++. This is a quoted character within a string. So this is one character. Is everybody clear on that?
And what is it equal to in
It's a new line.
assembly language, is it? Or sorry.
Yeah, you can do this in assembly language too. You can do this in assembly language, you can do it in C, you can do it in C++, you can do it in Java.
In machine code, is it 0, 0?
No, 0, 0 is the null. 0x, 0, if you do bash 0x00, 0, that's the null character. No, this is the new line character. It's the line feed.
Okay.
I'm pretty sure.
Yes.
Yeah.
Then what is it?
Because the other alternative is it could be the carriage return line, but I think it's the line. I'm sure it's the line feed, right? And you can look that up on the ASCII chart. Okay.
What it increments?
Okay. So now is everybody? Yeah, and in increments. So now actually, where is our arrow? Our line index is now out of the range of the string, but this is the new line. So I wonder if that's going to mess up the program.
Guess we'll find out.
I guess we'll find out. So let's go back up. So. Oh wait, where were we? When did this happen? Oh, this happened at next char gets.
Yeah.
So switch states, but now what's our state? SM. So we go down to SM, and now watch what happens. If is digit next char. Is digit next char? No. Else if next char equals what?
Bash in.
Bash n.
Yes.
Yes. Okay.
Number gets signed times.
Number gets signed times number. 58 gets 58 times what?
-1.
-1, which makes this what? -58. And if there had been a plus, this would have still been +1. If there has nothing, that would have been a +1. Okay. Number gets, and then what happens? State gets S dot stop. So this gets, here's our S stop. Are you with me? And now what happens? We break out of the loop. And furthermore, what is the value of number? -58. And what's the what is the value of valid? True.
So it's a valid number.
It's not only did it parse this, what did it do?
Converted it.
Converted it.
Can we go back one slide?
Sure. And I think what you should do is you should make sure you understand every else if else and see that it works with this machine.
Is number initialized to something?
Good question. Where did number get its first value when we did this? Where did number get its first value here?
In the second.
Well, number is attribute. So
Yeah, it is an attribute.
It got
Was
it
it
when
when
it
it
was
was-
5. So in the second state. So
It got its initial value when we went from here to here.
Okay, so it never got initialized.
It didn't need to.
Okay. So we're guaranteed that if we ever do sign times number, number is something.
yeah, because we could only call it if it was a valid.
Right. Well, I mean, there's nothing to prevent. It's undefined. If you call get number, even when valid is false, it will be something, but it's just undefined. Now, so was this cool? Now, I'm trying to remember what your homework is. Oh yeah, I remember now. Okay, now what you have to do, your job for Monday after spring break, should you decide to accept it, is to parse a hexadecimal number.
Okay.
So what's the input? What's the output?
Just like this.
So the
It just has to
input
be
is
hexadecimal, that's
hexadecimal.
it?
But what is a hexadecimal digit? What is a hexadecimal? Yeah, here, over here. What's a hexadecimal digit? It could either be 0. Well, it could be like A05. It could be lowercase a 1, 2, F. And you need to get it to its decimal value.
So we're going to be outputting the decimal value?
Yeah, and furthermore, there's some more restrictions. Not only that, but what about this? First of all, we want it to only take values between 0 and 64K. But this is legal. This is between 0 and 64K, even though what? Even though what?
6 digits.
Even though there's more than 4 digits. So there's lots going on here. A lot to think about. And not only do you have to check if it's a digit, what else do you have to check? Well, what are the hex ones?
Oh, it can't be past F.
It can't be past F. And then what's the value? What is the value of C? What's the decimal value of C? It's 12. It's not 2. It's not A minus.
Plus 10?
Yeah, whatever. But anyway, you just got a lot to think about.
Only positives?
I believe that's correct. Does anybody have the book?
It either has to be just positives or
Because
be
you said it was between
negatives.
0 and 6.
Yeah, it is. Yeah. So a hyphen in front would be illegal.
Right. And it's not,
But this converting to this converting to decimal is you need to do, because it needs to return an integer value. All the values in your project for all these constants will all be stored in decimal integer as decimal integer values.
and we don't have to worry about choose complement.
No,
Okay.
no.
Can we use the sign bit?
There is no sign bit. This.
Well, it's unsigned.
We don't know how many bits it's.
Yeah, read the specification in the, when you read the specification in the problem, I think it's all laid out. Now here's the thing, you guys. The specification, yeah, is a little annoyance now. The book is written assuming C++ as the HOL6 language. Therefore, when I wrote up the language translation principles chapter, I used C++. We are using Java. So the specification in the problem, it has some suggestions that are specific to C++ that don't apply to you because we're using Java. But so what I recommend, there's a bunch of little utility routines. You know, like there's an is digit, and stuff like that. And you know, Java has that kind of stuff, but it's kind of ugly, and I think it's better if you write your own. You know, your own little utilities. You know, like is digit, is uppercase, is hex.
Right.
You know, and then maybe one that returns the value if it is, or well, however you want to do it. But you write your own little utility things. You know, with your own little utility helpers with how to deal with characters and integers, but with hex. You know. Okay, so is that clear how to do it? And do you see, and it's using a direct code technique. And so this code is available for you online. What I recommend you do is make sure you name your projects as specified on the web page, and then what you can do is you can just copy paste. If you just click on this, it'll come out in text format, and you can just copy paste, because basically what you're doing is you're modifying this. And all the user interface stuff could be like this, but just make it relevant to parsing a hex number.
Cool.
Isn't that nice?
Yeah, I think it's cool.
I think it's way cool. Okay, good deal. Have a great spring break. See you a week from Monday.